Hey everyone, and welcome to the section about tuples in Haskell. So far, throughout the course, we have seen functions that work with the basic Haskell types, the booleans, the integers, the reals, and the characters. But Haskell has more types. Let's begin with tuples. A tuple is a structure type that allows you to store different type values on a single value. Very important, the number of fields that we may have is fixed. It cannot change, so it is static. Moreover, the types are of heterogeneous type. That is, they remain the same type. Tuples in Haskell are analogous to tuples in algorithmic or registers in Pascal or the data type of structs in C or C++. Note, here we have a series of examples of tuples in Haskell. The first of them is a tuple that groups three values, a integer, a character, and a boolean. Note that values are written between parentheses and they are separated by commas. Their type follow the same syntax. Types are written between parentheses and separated by commas. Then we have here another tuple consisting of two integers, the integer 6 and the integer 9. So it is a tuple of two elements, both of them integers. And here we have the type of this object defined. It is a tuple of two integers, right? Int, comma, int. And here in this example, we see that it is possible to nest a tuple inside another tuple. Note here that we have a tuple which first element is the value true, which is a Boolean value, and then the second element of this tuple is indeed another tuple consisting of two elements, 6 and 9. And we can see here the type of this object. It is an object that has, it is a tuple that has as a first parameter the Boolean value, and as a second parameter a tuple consisting of two integer values. Now, what can tuples in Haskell be used for? Imagine that you have to design functions that return more than one thing. Take a look at the function of the most frequent character. From a given string, it will return which character is the most frequent one in this string and also how many times this character appears. That is the number of occurrences in this text of this character. We see right away if we have the text avatar, we have this string and this word, and we want to see how many occurrences the most frequent character appears and what is this most frequent character. We see right away that this is the character A. Okay, this is the character that is most repeated inside this word, and it appears a total of 3 times. Okay, here's the first A, the second A, and finally the third A. So in this case, we see the output of this function. So this function returns that the character that is the most frequent one is the A character, and the number of occurrences of A inside this string is a total of 3 occurrences. Consider now that you want to design and program a function of time decomposition that from a given number of seconds in integer value, it breaks it down into hours, minutes, and seconds. The result is therefore a tuple of 3 elements. One integer for the hour, one integer for the number of minutes, and one integer for the number of seconds. And a possible way of implementing this function we have here shown. So the idea is that from a given number of seconds, that is this variable seconds, we will return the tuple HMS, where H is this value, M is this value, and S is this value. So here we are using the where directive. So we see that each of these values, H, M, and S, are defined inside the where construction. So as we see, we compute H to be the number of hours that we have within this number of seconds. So H is the integer hours that we have. in this number of seconds. So we basically make the integer division of the number of seconds by 3600, which is a number of seconds that we have in 1 hour. So with this, we have that h is the integer value of the number of hours. So once we have this done, we now calculate the number of minutes in its integer value. Okay, this is the number of minutes or integer minutes that we have on the remaining side of the second. So first we compute the remaining of this division. Okay, once we have the remaining, we just divide this by 60. So we have the integer value in minutes. And finally, when we compute the remaining of these seconds with 60, we will always have the number of seconds in s. Okay, so with this we have h, m, and s. You can try by your own to use this function in the Haskell interpreter and see the results. Very well. With this, we have introduced the concept of tuple in Haskell. In future lessons, we will learn how we can access tuples.